Hi everyone! In this episode, we mainly focus on the dynamic simulation of some small elements. I have imported the ground and the small stuff, some of which need dynamic simulation, just like the flying objects, leaves, and so on. As for these transport facilities, I'm gonna skip them. And done. Let's deal with this group first. You see there are leaves, plastic bags, newspapers, etc. They all belong to soft bodies. So let's get to it. Here I add an unpack node to convert them to polygons. Then bring them into new geo. There are many groups. Let's isolate the stuff as per the group they belong to. Of all the objects, some are organized and some are not, like the 3 leaves. Actually, for the organized stuff, it's inconvenient to control the number of the copies and distribution. I'll deal with this problem later. The leaves are operable, yet there are a bit too few. So drop a copy and transform node and make 10 copies. The leaves are too large. Add a transform node to scale them down. Here I put a human model as a scale reference. You see the leaves are of a good scale now. Hide the model. Next, let's get down to these organized things. What we need to do is isolate every element, put it at the coordinate origin and duplicate it. Alright, merge them all. Then add an assemble and pack them. Then we apply for each to loop through these elements. Before that, we drop an enumerate node to create an ID attribute for each one for future use. Then add a transform node to return them to the origin. Cool. So now we can directly make some copies. Create a box in the foreground. Then fill volume in it. Increase its subdivisions here. And scatter some points. Create a for each loop. Drop a copy to point to copy the stuff onto the points. Currently, this input geometry is a collection of all the stuff, so we have to isolate each one. Here we need to apply iteration. When the loop runs one time, the blast will isolate one element. Group here. Let the ID equal to iteration times of the loop. Now every element is selected. Yet the selections lack some randomness. So the rand function can be applied here. The rand function ranges from 0 to 1. So we still need to multiply it by the current iteration times. Besides, the ID should be integer, but the values we get from the rand function are float. Thus, rounding is necessary. Drop in the floor function and input backquote at the start and end. This way the results will be right. Set the group type to points. Cool. I also want to vary the rotation of these objects. Drop down an attribute randomize node. Drop in orient, which is a 4-dimensional vector. Set a larger global seed to vary their orientation. Next step is the dynamic solution. It's not very complicated, and there aren't too many settings. We first unpack these objects, and then build the basic Vellum workflow. Vellum constraints here is for setting constraints. For these elements, we set the constraint type to cloth, tick math, and thickness. Keep their default values for the moment. The third input of this node is asking for a collision geometry. So let me import the ground and the buildings on the left. Here, only the first building is imported. As the small stuff in the background is barely visible, no point to import other buildings to collide with it. This way, the dynamic solution can also be sped up. Here, using delete, we isolate this building. Come up here. I added a for each to run unpacking. But there comes a problem. The normal orientation is inconsistent. Thus, the following workflow will handle this. The same way as unifying the normal orientation of the simple buildings. Cache it out and convert it to polygon. Then, wire the collision geometries to the Vellum constraints one. Okay, let's get down to the Vellum solver. Check ground position first, which creates a collision ground. Jump to the forces tab. Let's set the direction of the wind. As the tsunami moves in the negative x direction, we set the value on the x-axis to -1. Here is only to set the wind direction. I'd like to set more forces to animate the stuff. Let's get into the Vellum solver. Add a pop wind. Set the wind velocity on the x-axis to -10. Set large values for amplitude and swirl size to control the overall dynamics. Then duplicate a pop wind and set small values for both to add some details to the dynamics. Usually, if we set a small swirl size, the amplitude should be down accordingly. Likewise, a large swirl size corresponds to a large amplitude. Concerning the wind velocity on the two nodes, it's good to keep one value. Start frame here. No need to leave too many frames for pre-simulation. The stuff is already well placed in the space, so a few frames are fine. As for the cache settings, I won't repeat them here. As you see here, this node reports an error when there is no cache loaded at this frame. We can jump to the load from File tab and set missing frame to no geometry. It's good now. Well, this is just my preference. Okay, let's cache it. You see, I cache it with the ground and the tsunami so that we can clearly see how the flying stuff is moving. It's good overall, though with some concern. First, it looks like the flying objects are falling down slowly. I hope they can roughly keep their height all along. So I reduced the gravity a lot to reduce their falling speed. Another problem is that the quantity of flying stuff is too small. In fact, it's not a big problem when we view it separately. Yet when we display all the elements in the scene, this problem will be much more obvious. Let's fix it. For more stuff, we can directly increase the force total count here. However, here I'd like to add some leaves only. Duplicate this chain and change the input geometry to leaves. Oops, I forgot the scatter node, so duplicate it. Take the count here up to 300. Disable the relax iterations to prevent the particles from being even. Let's cache it to see how it comes out. It's good overall. Only a small issue. We can see this leaf is a curl at this frame. Playing forward, you see it is being opened gradually. It's too soft and not like a real leaf. In fact, whether green or yellow, the leaves won't be so soft as paper or cloth. Maybe it's a flaw, but it has a negative impact on the realism. So let's fix it. After we select cloth here, there will be a parameter under bend stiffness, which controls how soft a thing is. The larger it is, the harder the thing. Set it to 100 and test it. After a few tests, I found 1000 is proper. Let's observe the leaves. Look at this leaf. It's not so limp as before, much more realistic now. As for the quantity of the stuff, we'd better not check it with a black background. It's not intuitive. It's better with all the elements being displayed in the scene. Okay, let's take a look. The current quantity looks nice. Alright, let's go on. Next, we get down to the things on the ground. So let's first classify them according to whether they need to be solved. These things, like traffic lights, street lights, billboards, road signs, etc., no need to solve their dynamics. Neither the guardrails here. Normally, these things won't be blown away by wind, but like some roadblocks, dust stuff, and the rubbish bins, they may be blown away. Based on the groups here, I isolate the fences. Merge them with the stationary objects in Alembic 14. Okay. In Alembic 12, let's sort out which objects are too heavy to be blown away. Then merge them with the stationary objects too. Of the remaining objects, some are in the background, thus it's unnecessary to solve them either. So we just focus on those in the foreground. We add a box to isolate them. And connect the remaining ones to merge 11. There is still some stuff that I prefer not to solve its dynamics. Select and remove these objects. Let's check out the objects in this alembic. Some of them don't belong to the soft bodies, then isolate them. So now we've got the stuff involving RBD simulation. Import it into a new geo. Then import the ground. There's no point to create constraints here. Very simple. Drop in a symbol, set their name as other, and pack them. Ground here, let's call it ground. Since it should be still, set its active to 0. Usually I add a transform node to lift up the objects a bit, because some objects may be intersected with the ground. After being lifted up, they won't drop under the ground in the simulation, and the intersection will be gone. Then create a dot, set the start frame to -30. Here we need to exclude ground, the collision object. get it into the DOP. Let's first create the necessary nodes. Import the ground and the isolated stuff. Take override attribute here so that the active attribute we set just now can be identified. Let's scroll down. Set bounds for both to 0. It's not needed. Here I applied a multiple solver because we're going to add some extra force. Drop a sub-solver, get into it, create an attribute valve. The settings are pretty simple. Just add a constant and a turbo noise. Here we set a small frequency. Then the simulation won't be too noisy. Turbulence here, a small value is good. As for the value of the constant here, we need to test it. Then output the result to force. Besides, I animated the offset here to get more randomness. So much for the DOP settings. Very simple, right? Then we create nodes for file caching. Select create points to represent objects. Then get the start frame of the file cache and the DOP linked. Let's cache it. Okay, it's done. Let's drop the transform pieces and take a look. You see a couple of objects are moving, which proves the force we set has taken effect. Yet the density value is not set properly. In fact, the larger it is, the heavier the things are, and the more difficult they can be blown away. So let's reduce the density and cache it out again. Okay, let's take a look. Now more objects are moving. Let's make a flipbook. This simulation contains all the stuff. It's good overall. Don't keep too many objects moving, otherwise they will be highlighted too much. So a few are fine. Let's go on. There are packed objects. Later we'll shade them, so let's unpack them and merge them with the ground. Well, when observing these objects closely, we can see there is a small gap between them and the ground. Like this. This problem seems like not a big deal, but in the final render effect, the gap will become obvious due to the lighting. So I add a transform and make them down a bit. Okay, let's cache them out. Awesome! We're done with the stuff dynamics. Catch you next time.